body, the way the body communicates. You saw a lot of the nervous system in Phys 1, and so it's mostly neural. Okay? What we're focusing on is endocrine, which is me communicating through a hormone produced in a gland some distance away, sent into the blood to communicate. These are just definitions. That's why I don't want to go too far. It's kind of a nice intro card. Then we have specific things related to brain communication. That would be neuroendocrine. Then paracrine. We haven't really gotten to a good example of that, where a gland is influencing something nearby. Okay. And then autocrine is what you're going to get when you get into the immune system, where the cells can almost self-regulate. They rev themselves up. I don't know what superhero you kids watch that does that, but anyway, they sort of cytokines are specifically to the immune system. So this was just, hello everyone, we're getting an introduction to that, okay? But as far as the questions go, they're probably the only thing I would answer, like a definition. So a neurotransmitter released at a synaptic junction, what kind of communication is that? It's neural, that's neural. That's why I say you should know this. A cell secretion, and it's affecting a neighbor cell. Paracrine, they're just next door. There was an opening slide that did this. And then specialized glands from far away. That's what we're doing. We're doing the endocrine system. So that's what I wanted to get into. So I don't think of those as mostly for like exams, because that's so far away and remote. So I just want you to go to the endocrine. Here's what I do want you to know: the functions of the endocrine system. Okay, and so we've seen some of these. So you should know broadly they're going to be involved with growth and development, reproduction, blood pressure, water electrolyte balance. We haven't gotten to that. The next part is really important, okay? Because this is what I always do in every class. We want to be able to recognize whatever we're doing. What gland are we talking about? What hormone does it produce? Where is its location in the body? What's its target? What are the effects? And if there's anything specific about the process in which it is made. And then the final one is, a lot of times we illustrate this by showing either a deficiency or an excess. That's a template. And if you look back, pretty much what I've done in every class. We took growth hormone, right? Where is it made? Okay. What tissues are affected? You know, if there's a special mechanism, I talk about that, and then we talk about clinical states, deficiency and excess. Does this make sense? You're a little confused, or you're staring at the TV. So I want to go all the way to the beginning. And then I gave you the last part. So some hormones have systemic effects and some have local effects. Can I ask you stuff? Oh, good. Give me an example of something that would have a systemic effect.
Cortisol.
Cortisol has broad effects. Someone else?
Growth hormone. Growth hormone.
Growth hormone. Okay. Growth hormone, broad tissues. Thyroid is another one. Why? That's metabolism. That's pretty much catching everything. So that's what I mean by you have to recognize in some very, very specific ones, some have systemic, some are only local. The easy one in the lecture is, what does thyroid stimulating hormone do?
Stimulates the thyroid.
Yeah, exactly. That's what I meant by focal. And then you need to understand the concept of what we started at the beginning. You're all experts now. But gland hormone production, anything special about how it's built. Its target, because it's not going to affect everything. It has to have specific target tissue. Okay? To be sensitive to a hormone. Yeah, it's going to have the receptors. Okay. So it's concentration of the hormone receptors. I don't know if we got to upregulation of the hormone receptors yet. Okay. Do you want me to go over a PowerPoint?
Sure.
It's our first time. I'll go slowly. All right, you can see what I'm showing you now? Week 1? All right. Your charts are a fast review slide. PowerPoints are a little bit slower. So if you're trying to save on time, right, and you go like, well, what's my base information? Usually the charts are going to give you everything you need to know. The PowerPoint, I'll do the PowerPoints because I want to see if there's anything subtle that I'm talking about that I thought, oh, that'd make an interesting question. By the way, if I start saying, hey, that would make an interesting question, someone should write that down and hand it to me. Make it an interesting question. Do you see the PowerPoint?
No.
Of course not.
There
There you go, there you go. All right. So I'm going to go very fast until you slow me down. This was all just the objectives, what we're supposed to learn. Biggest takeaway from this, I'll go over this, is in addition to the nervous system, which you learned in Phys 1, we have the endocrine system that amplifies The general questions are, how is it different? And we just kind of went over that. In both cases, the philosophy I like to use is it's changing the cell's behavior. It's going to do something different in the presence. So we have our primary system. See how small the print is down here? That's to give you something learning, but I'm not going to emphasize that in my exam. So we also have other things that you learned about that act in a similar way. Okay? You should know these general definitions, because sometimes that's just for the boards, they'll ask you everything. So this is the way the body communicates. We do it through nerves. We're talking about doing it through hormones. Then you have these specialized hormones within the nervous system. This is what we talked about before. I'm not going to do this again. All right? Could you recognize a definition? Okay, if need be. All right. And then again, the general functions. Okay? Broad brush, because it was first class stuff starting with this. But all of these things, we do individual projects, but big projects are usually hormonal. Reproduction, growth, okay, energy metabolism, that sort of thing. You may see something like this, okay? A comparison of maintaining homeostasis. Nervous system is rapid, right? Direct communication from neuron to target happens very rapid. Endocrine, what's the difference? Hormones entering the blood, okay? Their target can be some distance away, and it's usually a prolonged response or a long response. It's not as fast as the nervous system, but they both work hand in hand. I'm trying to think like the board's in like me, okay? This is just a definition, this is just a level 1. Would you be able to recognize what paracrine meant? Would you be able to recognize what neuroendocrine meant? I mean, those are just definitions. All right, it's my first review with you. Let me say that when it comes to writing the exam, I eschew these things. I don't worry so much about them, because to me, looking back, these look small, so I'm going to go much faster. Is everyone okay?
Mhm.
I'm skipping this. But if something shows up, you can now. All right. Comparison. Okay. Long-term projects. Oh, the last one is important too. Thought, mood, behavior. We've sometimes talked about that. Okay. This is what you need for every time we have a class. You want to know the gland, the hormones, the target, the specific mechanisms, any other regulatory factors, and clinical conditions of excess or deficiency. See this slide? You take that with every class we did and see if you can fill that in. We'll do that now. Okay. This again is showing you the broad range of things the endocrine system does. Rather than asking about that, I'll ask you about the things we've already talked about. Which ones deal with growth? Which ones deal with metabolism? Which ones deal with glucose regulation? Okay. And this, I could ask you something. So some have very broad effects. So when we say growth hormone, you have specific structures, all right, being affected, bone and muscle, but they're very systemic wide. Dramatic changes during adolescence, I consider that systemic. Thyroid hormone, what's its effect? Again, it will be metabolism. That's all the cells working better. And insulin can be considered systemic because it's eventually going to affect every cell because it's dealing with energy. Local is very specific. They do one thing. Thyroid stimulating hormone just stimulates the thyroid gland. What identifies a target tissue, a specific receptor? Okay. You know basically the difference between steroid and protein. What I will ask you is how they work. That comes up a lot. So let me see if I got a slide for that. Okay. So we'll hang on to that. Yeah. The only one that's really made a tyrosine, we'll talk about that. Okay. So proteins and peptides. These are going to be made inside the cell. Okay, they're stored until needed, then they're released. Okay. They bind to the outside of the cell. Give me a buzzword or phrase I've given you about how steroid proteins or how peptide proteins work. You have to be a little brave for this thing, bro.
I said widgets.
What?
Widgets?
Widgets? Well, we're all widgets deep down, but there's two big differences between steroids and protein. Let's try to do steroids first. What's the target of steroids?
Nucleus.
They're gonna find the cell. Are they going to go inside the cell or stay outside?
Inside.
They're going inside. They can get through the membrane. When they go, the reason why they're going inside is they're going to bind to something. They're going to switch something on. What is that?
The transcription.
Well, it's been a while, hasn't it? I'll just talk to you then. All right, steroid hormones, here's one much about steroid versus protein. Steroid hormones, because they're oily, will just move right through a membrane. Once they're in the membrane, they head straight for the nucleus and the DNA. They switch on DNA. Steroid hormones are about building proteins within the cell, primarily. That's why you see them for growth, reproduction, that sort of thing. Very powerful, right in the cell, they're heading for the DNA. A protein-based hormone, by and large, and the thyroid dresses this up, is, it can't get through the membrane, right, 'cause it's got a charge, will stay outside the cell, bind to a receptor, which will create a conformation change. Something has to be released inside the cell to communicate. And the general term? Second messenger. Cyclic AMP, something. Usually something with phosphate. You're switching on a process, so it's going to need energy. So they stay outside. You know, which of the following are characteristics of protein-based, something like that? I'm trying to think of the old questions. Okay, and so what are they doing? They're altering the metabolism in the cell. The cell is going to change what it does, or change its behavior. Not making more stuff, okay, that's a steroid thing, but it's working a little bit faster. Insulin, when that got involved, says we need you to actually be able to take in glucose, store it, that sort of thing. But it stays on the outside, it doesn't go into the membrane. Ooh, let's do some specifics. Okay. And this is what I'm showing you. This is the examples of second messengers. So again, cell activity and metabolism. We're still on level 1 though. This is just showing you them all. This is showing you steroids. Pasting cholesterol will slide through a membrane. When they travel in the blood, what's unique about them? They're oily, so they need a carrier protein. Okay, they remain in circulation much longer because of the carrier proteins. Okay. The cause. Here's a possible question. Which of the following? I'm not going to do the whole question. Which of the following hormones requires a carrier protein? I have to give you the full question, but see what I'm saying? And I'd give you 4 choices, and you'd have to be able to pick out the one that was a steroid or not. Thyroid. Dun, dun, dun. Remember, thyroid was a special case. So we have general stuff now. You were just babes in the woods at the beginning. Now you're experts. Steroids do this. Slide right through. They're going to bind to a receptor. They switch on genes. We are making proteins. We are building stuff. You can lump your steroids together. Really, we've only talked about the adrenal cortex. We haven't gotten to reproduction yet. So that's the one we're going to deal with. These are all labeled words. Okay. Then we have these special subtypes. We had the amines. The one we spent the most time on was thyroid hormone. Basically, that would be a great question. It's either part of a question, but something about remembering what it's made of. Made of amino acid. Which amino acid? Tyrosine. Tyrosine is the foundation. Okay. There are other things we'll come across, and then the thyroid gland is actually going to produce hormones based on that. The same is true for the adrenal medulla. Epinephrine and norepinephrine are based on amino acids. We didn't even talk about that. Now, I use this because every once in a while we do a much deeper dive in terms of how the process was made. And I try to keep it somewhat condensed for you. So we have this again when we talk about thyroid hormone. This is what I want you to appreciate. The thyroid cell itself is going to be like any other cell and make protein. What's the base protein that the thyroid cell, right? Yeah, the follicular epithelial cell is going to be making. Base protein. It's on the slides. Okay. They're going to tell it to make a protein. So I'm making thyroid hormone yet. Oh, this is a good time to segue into thyroid. So it's making a base protein. Okay. The base protein here, oh, I can do this, is going to be thyroglobulin. That's actually what the cell makes. It's got DNA that says we can make this. Now what are you going to do with it? Well, in order for it to actually work, this is unique to thyroid. This is kind of fun out here, actually. Is we're going to need a couple things. One, we're going to need something from the diet. You know what that is? Iodine. So we need something from the diet. Okay. And then we're going to actually take this through the cell and put it in this big vat and have it processed through a number of enzymes. You have to know every step, but you have to know maybe the critical enzyme that keeps it going. And what's happening is this base thyroglobulin is having various numbers of iodine being attached to it. The primary enzyme that I want you to know is the one that's involved in the most steps, right? And that's peroxidase. So you'll find it highlighted in red in your PowerPoint. Okay. So that's how we take all this and say, okay, now how does the iodine get there? Okay, does the body make it? No. Gotta come from the diet. The only other thing is it's got a co-transport, but that's not as essential to me, that's just getting it in there. So I need you to know the cell itself can only make the protein. Iodine must come from the diet, and actually to form this, there are several steps that are happening, in the follicular lumen. It's like a big vat, it's just brewing this stuff. And then eventually that will pass and will be cleaved to form the two hormones, T4 and T3. Supplemental questions, which is the active one, which is the most abundant? You don't have to answer, but you're saying like, what do I want you to know? I want you to know the important stuff, board-like stuff. Know peroxidase because it's common. Okay? You also need to know, we did this in lab, what's the enzyme that converts, 4 to 3. Remember Odin? Yeah. Well, you won't forget now, would you? It's got an Odin in it. Something Norse? Okay. All right. This was just to explain to you that some hormones are made from a simple amino acid. We've got a few things here. Some are neurotransmitters, some actually qualify as hormones. But thyroid comes from tyrosine. Tyrosine also is the chain that develops dopamine, norepinephrine, epinephrine. We haven't talked a lot about dopaminergic neurons. You get that in other classes. We certainly talked about thyroid. We certainly talked about norepinephrine and epinephrine because we did the adrenal gland. And those are formed in the medulla. So this might be one question about, I'm just making them up as I go, which means I'm probably going to forget them. But I just look at this and I go like, oh, that'd be cool. These two hormones share a common base element known as, right? Somewhere in letter C would be tyrosine. Does that make sense? You look right. You're staring at the screen. I don't know. But this is what happens, is I sit down with this and I go, hey, that's a pretty good question. But they don't know that. Okay. Wait a second. Iconosoids. It's a lot of fun. When you really get into these, when you're doing the immune system. Okay? The one that's probably most recognizable are prostaglandins, which are released in inflammation. But again, when are you going to really get into the mechanisms and see this a bit more? Because we only have so much time, we're probably doing, looking at the immune system. So these are also lipid, these are also oily. And, okay, this is kind of fun. You should know the general things about hormones. They give you this chart and another chart, but how they're made, how long they last, are they stored, do they need a special carrier which lasts longer, you know what I'm saying? So for lecture 1, the questions I would form, it's only a bit different, but they're general properties of hormones, how they work, the fact that there's 2 classes. Is this okay, without giving too much away? Okay. Because it's more fun to
Feel
go.
free
to verbatim.
What?
Feel free to verbatim if there's confusion.
At this point, I is anybody recording this? No, of course.
But if we remember it, we can send it to you to remind
If you remember it, yeah, but then you're gonna go like, you read anything he said.
Summarize it for him.
Yeah.
Clean it up.
Really important that we understand the mechanism of regulation. Okay? And this is the difference between negative and positive feedback. What's the most common form? Negative feedback. Okay. Did we talk about a feed forward yet? What did we talk about?
Yeah.
Which one?
Negative feedback?
Oh, we talked a little bit about oxytocin. We haven't studied pregnancy, but we do have an example of a feed-forward mechanism. The other one would be blood clotting, but it's not so much time. These are the different types of mechanisms. We're focusing on the endocrine, however. Okay, humoral, neural, feedback. Again, I got so much to tell you, I don't want to give you the little stuff when we're talking. Otherwise, the lectures will be really short. This you need to know. For each hormone that we talked about, you need to know its regulatory mechanism. And they start off, like I told you, like I promised, like thyroid hormone, and then they get a little strange, like growth hormone, where it's not quite that 1, 2, 3 anymore. So you have to appreciate that. Because let's take growth hormones for an example. Growth hormone, right? You start in hypothalamus, right? Then we get our other release, and then we finally get growth hormone being sent from the pituitary. Is growth hormone going to increase protein synthesis in muscle or bone?
Yes.
It is. Is it going to do it directly?
No.
There you go. Don't fall for that trap. So that's an example where I got growth hormone, you know, it's muscle and bone, but like I said, which of the following has a direct effect? It has a direct anabolic effect on muscle and bone. You would know that that would be the IGF, that sort of thing. So it's that kind of teasing out the information, but using specific examples for study in your own class. Okay. Done with that? Feed forward. Okay. Here's an example of a feed forward mechanism. Explosive events. And yeah, these are all we've talked about actually. We did talk about neurostimulants because we got to the adrenal gland and what hormone is released from the adrenal gland via direct neural stimulus. Up there in the picture. You've got the cortex, and then you've got
Medulla.
yeah, you've got the stuff inside. That's the epinephrine, norepinephrine. That's the center. That's just a pipeline from the sympathetic. I shouldn't say that. That's a pipeline from the sympathetic nervous system. It's a preganglionic right there. So when the sympathetic is firing, right, the nerves are firing. The norepinephrine's being applied to muscles and all that other stuff. But then, boom! It just throws all this stuff into the blood, which revs up everything. Right? That's unique. Okay, the outside is following the things we talked about before. Oh, it's going to come from ACTH, right? Sorry, CRH, ACTH, cortisol gets released. Does that make sense? So there's, most of the pattern is there, but there's little changes. Okay, so this is again showing you the humoral nervous system. The best example was the adrenal medulla. This is most of what you've been working with some subtle changes. Okay, and then the responses. Oh man, this is so general. Okay, so I'm trying to think of something I could use. And I got a couple of things here. And you probably intuit it. So chronic maintenance is thyroid hormone. Why is that a chronic? What does the thyroid hormone do? That explains, like, you got to keep it at a nice level all the time. Because that's dealing with metabolism. You can't have highs and lows. It's supposed to be humming along. Okay. What about a stress response? Epinephrine. Oh my God, tiger! No, I fell for it. Anyway, if you would believe me, you would have gotten something like that big spike when you're having a stress response, right? A sudden bolus of epinephrine. That's not just a midline. And the last one, you know, the best example of cyclic changes in terms of hormones would be female reproduction. Where males are more straightforward, and it's, you know, monthly cycle. So we really haven't gotten to that. But if I asked you just what to the following would be a good example of cyclic hormone secretion, you'd be able to figure that out. Okay. Can't ask you that. All right. You're not getting all the secrets. All right. Mechanism of action. These are the things I do ask you about. Difference between peptide and lipid. I already talked about this. One is outside. Secondary messengers. We're changing the cell's behavior. Its mechanisms inside. Lipid. We're going to be building stuff. You can watch YouTube. Okay. Hormones are first messengers. And you had some of this in Phys 1. Do you understand the concept of a second messenger? Okay. Which class of hormones, steroid or peptide, use second messengers? There you go. Perfect. Something we notice about second messengers. Okay? Notice a lot of them have phosphate attached to them. Because usually they're going to trigger some energy producing. There's going to be activity rather than building protein. The other big player is calcium. Calcium is a second messenger. And the thing that you do know from the past is, wow, whenever muscle needed to contract with a little more force, it needed a lot of calcium. So you can hang on to that. Skeletal, smooth, uterine contractions. You know, part of what oxytocin is, we're going to bring calcium in here, and they're going to get faster and they're going to get stronger because of the increase of calcium in heart. And the other two all have phosphates, and you can snap a phosphate off of anything that helps it, and it releases energy. You're used to ATP, but phosphate-containing molecules, like the following, also provide that energy to do something. Big wave in back.
I was making sure that they got the door.
Oh, okay.
He was waiting.
I think Brandon has a question.
I think it's going swimmingly. I don't know what you.
Absolutely.
I'm having a grand time.
Boop. You know this concept? First, second messengers, okay, forming a complex, changing something inside. I want to get to some specific stuff. Second messenger. That's where G proteins come in a lot. Okay. There's a whole list. I want you to understand, I don't want you to memorize as much as understand a process. So even if you can just recognize how things work, and you go, I don't remember mentioning this, you would go, that kind of sounds like how a protein-based hormone works. Right? We're not making stuff, we're doing this, yes.
I have a question.
Sure.
So for this second messenger, like, is that always whenever like ATP is turned into CAMP? Is that like that? That's what the second messenger means?
You're talking about like skeletal muscle?
Well, yeah, but like just in general.
Yeah, that's the one you're most familiar with, and that would qualify. But I want you to appreciate all these other things that are also. A second messenger does this. Look, we need a change going on. There's some signal out here, but it can't get into the cell. But it's going to create a cascade that creates something inside. So what happens is, where am I? Okay. So using the skeletal muscle, and ATP is the ultimate energy source. But what was actually, the neurotransmitter lands, goes across the membrane down into the cell. What gets released? What shows up? Swimming around the muscle all of a sudden. Calcium. That's your second messenger. That's the link between this. Why? Because when calcium shows up, it'll do this, it'll pull off, I can't remember all this actin-myosin stuff. But anyway, it already comes up, it's already loaded. It's spring-loaded with the ATP. And it's gonna do this, grab, pull. And then you need the ATP to actually push it off and reset it. That's how the actin-myosin actually work. Does that make sense? So ATP is an example, it's the one you know. What I'm telling you is, look for something with a phosphate. Look for something that can create energy. Calcium is a very common second messenger. But it doesn't have phosphate, and then you go, but it doesn't have phosphate. So I'll tell you that. They'll be digging for phosphate. All right. So the last thing tells you all the things the second messengers do. Okay. I did mention G proteins because I like reading papers about that. But the reason I really mentioned that is so you can understand how they actually work. Sometimes this gets glossed over, but this is that communication link. So here's a receptor, okay, and you're going to have a hormone bind there. This is going to be protein-based. So what has to happen? This G protein here has something with phosphate on it, and that's going to move to another protein, its target, and you're going to use that energy to get a conformation change, something going on that produces something. These are general, but I think all this talking like maybe 3 questions on this.
3.
That's not true. All right. This is saying the same thing. See, first messenger, receptor, G protein, enzyme. Okay. Now whatever the second messenger is, GTP, calcium, that sort of thing. Did you have this in biochem?
Yeah.
Oh, well, all right. Then I don't have to sweat so much. I just want you to know general stuff. There it is again. Here it is again. Here it is again. Sometimes it's just plasma membranes, phospholipase. This is more fun when I'm actually giving you a big example. You're getting a lecture on everything, but it's not necessarily what I'm going to ask you. I do like asking you about this because we've had a few examples. What do we need to know? The receptors inside and going directly to the DNA. We're binding to that. Where have we seen this? What are glucocorticoids?
Cortisol.
Cortisol. Yeah, cortisol is our best glucocorticoid. Aldosterone behave like this. We did our thyroid hormones. We haven't gotten to the reproductive yet. Transfer of proteins. So this is kind of a nice question. So we said that steroid hormones have to be carried because they're oily. So they need something with a charge of proteins to hold on to them. what is the benefit, what are the effects of being bound to a carrier protein? One, it's gonna alter the clearance rate. It means they hang around a lot longer, right? Slowly releases some of the hormone and there's a solid spare left behind. It increases the half-life, the duration of this particular hormone, okay? And then as far as removal goes, I don't think I torment you too much, but for a lot of these hormones, they'll let you break down by enzymes. They'll get to the target tissue, do a good job. But some of these are going to be cleared by the liver and kidney. Don't lose sleep over that last part. Okay? That's the other stuff that I do. This I do want to know. I want you to know. I'm going to ask you questions, and we have examples of this, and I can fold it into an example if I can get this moving. There you go. We talked about up and down regulation. Before I do this, I'm just prodding you a little bit. Can you think of a hormone where we talked about up and down regulation? Sorry? Insulin, okay? So this is where I started talking to you. He just goes on and on. But then we have a specific example. So I fold this into basically insulin when we get to it. And the concept is this, okay? The target tissue has a specific receptors, but the number is not constant. There are times when more receptors will show up. That's upregulation, okay? And then there is downregulation where they're not responding. In the case of insulin, we talked about downregulation. Remember? It's like, what are you doing? There's glucose, there's insulin, okay? Upregulate. Insulin unlocks the door, we get the glucose, we store it. All of a sudden, there's just too much glucose, now it's becoming triglyceride, receptors are gone, not responding to the insulin. Type 2 diabetes, it's no longer responding. Sometimes there's upregulation, an increase. The body's going to be more sensitive to this. The fastest one that comes to mind is the upregulation of certain receptors when people get addicted to nicotine, right? Oh, this is pleasurable. Let's get more receptors. We like this. We like this. Then you suddenly take it away. I might kill someone. Anyway, really addicted. That's the two. That's upregulation. Example of upregulation, downregulation. Okay. All right. Need to appreciate. I'm trying to think of how I would word this, but the concept of dose response. That's in everything else. So you're adding some of whatever it is, hormone, medicine, whatever, and as you add more, you usually get more of an effect. Until what? Saturation of the receptors, something like that. It's going to plateau, right? But in the early stage, that little S-shaped stage, that's called our dose-response relationship. So in that small space going up like this, I add a little bit more, stronger, stronger, stronger. At this point, we've topped off all the receptors. It's not going to increase at all. Okay? And the other one is, if it's below that, you're not getting any reaction at all either. Okay? This is just a definition. It's a level 1 question. So, which of the following best describes sensitivity when it comes to hormones? Yeah, I know, just with it. That's all I would do with it. I'd rather give you examples. That's more fun. This is more fun. How can you change sensitivity? Okay. We can change the number of hormones, the number of receptors, or you can alter their affinity. Okay. Meaning they're more likely to respond, or the inverse is they're less likely to respond. Okay. Downregulation, just the opposite. We talked about that with insulin resistance. We can see that with thyroid dysfunction. There are certain diseases where they're just not making the receptors anymore. Some cases of oh, that's me. Okay. So downregulation, overexposed, it's like we're not listening to you anymore. Let's get to some specifics. Diamond, unknown, redundant. Okay. This is all the important stuff we learned so far. More important stuff. This is very general, folks. What I tell you to do with this is just start applying it to everything else. Here we go. But you want to know this chart. It's a nice, easy chart. You're going to get a few of these questions. They show up on the boards. How do you know which does which? Okay. That makes sense. What do you want to talk about now?
How many questions will be on the exam?
Lots. 60 to 65.
65?
Here's my thought on that.
More
We do
questions.
50 questions. Every hit you take tends to get devastating. Whereas you have a little more wiggle room with more questions. I know students freak out about that, but a lot of them are level 1, you're just flipping through them. And it gives me more cushion, in terms of like how it affects your grade. And you have ample time, so it's actually a little bit better to have, you're rooting for 60 versus 65. But you know,
5 bonus
I've done
questions.
50 and people, you know, you get those 4 souls who crash and burn. You go, this is the negative one, QBC, what's it?
Do we have all 2 hours, or
We have all 2 hours?
how long do we have? 2
Oh, for the actual exam, that's another good point. I'm just putting it up for the day. I think I'm starting at some absurd hour in the morning. Can't post it. Can't remember if I said 6 or 8. I'm just going by habit from last try. So it'll be open early in the morning and it will close late at night. But you will only have 2 hours to do the exam. Does that make sense? Because it's got a time. So you can take it anytime during your nice Wednesdays.
65 hours. Done.
Yeah, not such a big deal. A little hard to understand, but not too bad. Let's do more stuff. How about something where you have to memorize stuff? Didn't think that was gonna happen. Wait a minute. Am I missing a PowerPoint?
Can we also use scratch paper?
Can you use what?
Scratch paper? Sorry.
No,
Okay.
there's no math. Gotta use scrap. We're on Proctorio.
I just like
I'm
to
watching
write.
all of you at an incredible rate of speed like this. And if I see you writing, you get flagged. Right? You should, at best, you can do this. If you have a beard, you can do a little bit. But yeah, don't do that. It's not a scrap paper thing. It's in your head.
Professor had to raise his hand and flag them because they're like joking. It was so funny to watch you almost like.
Let's go right to the library. Did I not put the PowerPoint for the hypothalamus stuff?
How would we?
For which one?
How would we know?
Yeah, exactly. Maybe not the right one.
Yeah, I don't think I did anything
I
specific.
don't think I did. Oh, Dr. Moses. I had so many things I wanted to ask. But I can't now. Good thing I found out. I'll have to modify them. I'm gonna give you a real quick hypothalamus question. No, I won't do that. All right. What will I have to do? Probably flood you with thyroid stuff. Do you at least know the hierarchy? Here's what you do know. You know some of the hierarchy of, like if I gave you the hormones, like corticotropic release hormone, ACTH, and target. Yes? Kind of?
Kind of.
Seem unsure. Because I can hold that for the lab test. Because we did it in detail. Like,
Okay.
pretty much crush it. Ma'am.
Whenever you have hypothyroidism, you have high TSH levels. Is that because it's just not being secreted enough? So that's why you have high levels? Or why do you have high levels with
Okay. You come upon something that's classic in the boards and the one we always use. That's why I want to get to thyroid. Thyroid is the classic example of can you figure out where the problem is based on that, based on what's elevated and what's not. That's really what it is. So I'll use this. You also had one from the lab as well. So we'll go over that. This is structurally what's unique about the thyroid. Okay. You need to know that it's unique from other tissue. You have the actual cells that are forming thyroid gland. These are the thyrocytes. And that in the center, we talked about that big vat of protein. That's thyroid globulin. So one question, I'm not giving any guarantees, but one of the things I could say is the thyrocyte actually forms which of the following? You know, and the full name for, you know, triiodonine, that's T3, parentheses T3, T4, thyroglobulin, or something like that, you know what I'm saying? So the cells can only produce a protein. They're not producing hormone, right? The follicular cells are producing the base. So you need to know that. That's separate from regulation, which I think you were asking, which is, here's a patient, maybe I give you a history, sometimes I just give you a lab. And you have to figure out what the problem is. So they have, I'm doing this off the top of my head. So we have high levels of TSH, okay? It's late in the day. High levels of TSH. What can you tell me about their level of thyroid hormone?
Hi.
It would be high.
Sorry?
It would be high.
Would you have increased
Oh, just realized I got two answers.
Can it be high as well?
Sorry?
If it's all working properly, can it be high as well?
Well, it can't be working properly if we're doing this.
Okay, that's fine.
Then it's low.
That's fine.
There's out of the two answers, and might have to stop and think about this. Unless you can even give
It
me the
could
two
be
answers.
low.
Huh?
It could be
Let me do it the other way. I won't pick on the pituitary. Pick on the thyroid. Person comes in, all the symptoms of hyperthyroidism, right? You're going to draw blood. What do you expect the TSH level to be? High, low, or normal?
Low.
Huh? I know, I just forgot what I said. The person has all the classic symptoms of hyperthyroidism. I'm sweating, I'm losing weight. Okay? You send off a lab, what is your expectation for the TSH level? Low. Low or none or something like that. But you know, if your choice is where it's elevated, it's normal, it's low, it's something I have to make up. Pause for a second. That's a classic question. Thyroid is a classic endocrine condition on the boards where, because it's not all that complicated, you should be able to recognize from a test what's going on. At least as far as, you know, I'm just giving you a TSH level, and the TSH is low. Would this person be hypothyroid or hyperthyroid? Hyper, right? They got low TSH. You have to infer that the thyroid is making all this thyroid hormone and shutting it off, right? We wouldn't find it in the blood, but what would be going on with their TRH? TRH, thyroid release.
It would be,
Also thyroid hormone.
As well.
it'd be low.
Yeah, it's going to shut off. It's going to shut off the pituitary. It's also going to shut off the thyroid. All right, I went kind of fast on that. Does that make sense to folks? Watch carefully how I phrase the question. I have a patient coming in and I give you all the symptoms. So the idea is I'm leading you down the path for either hyper or hypothyroidism. You go, I already have a thought. You know, if they're sweating and they're complaining about losing weight, irregular menstrual periods, and stuff like that, you go, sounds like a hyperthyroid individual. Let's run something from the lab. Okay, we're going to get a TSH level. One question would be, which of the following would you anticipate for a TSH level? Okay, you would expect the TSH level to be high, low, or normal range. Very hyperthyroid, what would TSH be?
But what if it's generating it, so you have a tumor generating it, would that affect it?
Where's the tumor? In the thyroid?
Not in the thyroid, in the,
Anterior
in the
pituitary.
pituitary.
Oh, in the pituitary? Don't do that.
Do that.
Because then I'd have to tell you more. You could have that, but I'm not going to go crazy because then you have to look at what if. I could do this, okay? I could do this. Oh, I forgot what I was going to do. Yeah, bummer. I was going to go with a tumor in the hypothalamus.
Okay.
Right. So you're not producing any of the following, blah blah blah.
Okay, that makes sense.
Yeah, that's where I think you were going. So if you're not producing any TRH, you wouldn't have what in the blood?
Then that wouldn't go down.
Okay. Would you have any thyroid hormone if they're not producing any TRH?
No.
Would you have any TSH?
No.
Ooh, there you go. All right. Does that make sense? I went kind of fast. Everybody comfortable with that? I'm standing over here in embellishment because I want to make sure we're on the same page. This is our first time doing this. That's what I mean by when you get comfortable with it, and then you just, this is what they used to do with some lecture, and then they go, well, what if I did this? What if I did this? Start with your foundation, because if you get lost, you just go back to that. You go, wait a minute, I'll draw the little picture. Oh, no drawing. I forgot it's preparatory. What's going on there? I don't know. Using sign language. But see what I mean?
Yeah.
You were doing what I want you to do, and also in your head you were kind of like, how can I create a diabolical question? I do that all the time. But it's just getting you to understand the mechanism. Yes, sir.
So would it be proper to say that TSH is part of a negative feedback loop, or is it its own separate mechanism?
The entire production of thyroid hormone, okay, is involved in a negative feedback loop. It's just a term for when you have an excess of the target hormone, that information it's what says it to shut off. Let's do it the other way. Thyroid hormone is low, the blood goes through the hypothalamus. What will the hypothalamus produce?
TRH.
Here's your TRH. That will go to a functioning pituitary and cause the release of what? TSH, and you'll make thyroid hormone. And it's just doing its job. But if it suddenly went, to excess, what would you not? You'd see a lot of T3, T4 in the blood. What would you not see in the blood? Or I don't want to say it like that, but it's also too easy. What would you expect in terms of level? And that's the question I had before. You draw the level, you draw blood for TSH, and like the thyroid's gone into business. Would that be high, low, or normal for TSH?
Is it hyper?
Yeah, they're hyperthyroid. What would you expect the TSH to be? Everybody okay? No? All right. I don't have anything to draw on.
Oh, there's a whiteboard right there.
Where?
Right there.
It's got wheels.
So, see, in my head, I'm going like, well, that was the easy one. But just to remind you. Yeah, it's only been an hour. How far have we gotten?
Week 2.
I will say to the last one of you, shh. Here's what I'm saying. So, you need to know the pathway. So in the hypothalamus, there's a hormone called thyroid release hormone. This will influence the anterior pituitary to release thyroid stimulating hormone, which influences the thyroid to produce T4 and T3. Quick questions, because we've already done those. Which of those is active? T3. What's the enzyme that converts it from 4 to 3? Iodinase. Excellent. All right. So as long as there's enough of this, right, this will maintain, and then the level starts to drop. So say this drops. This level drops. Thyroid's not making this. Okay. Listen carefully. Okay. What would happen to the TRH level?
If it drops.
Would go up. Could we get that in a blood draw?
No.
Oh, drilling holes in people's heads. I advise you against that. Anyway, we could. Why? Because it's in the capillary system of the hypothalamus. But if I phrase it differently, if I didn't say blood, I could say what's going on with the TRH. You would go, it's increased. Notice how I threw that curve?
Yes.
The board likes to do that. What would you see in the blood? Oh! Down it goes. But you will never be fooled again. Okay. What would we expect for the TSH level?
It's gonna go.
Low.
So this is not, we're not making the thyroid hormone anymore. Is that correct, or is this?
We're not.
That's not what I said.
Wait, we are.
Yeah, it was low.
It was low.
Isn't anyone paying attention to me?
Yeah, the arrow is halfway pointing down and you can't just.
Arrow's pointing down, so we're low thyroid.
So it's gonna increase.
And that's why I said, like, would we see this? No, but you know it would be elevated. What about TSH levels? That'd be elevated. I can't do this. You have to be comfy with thyroid by now. Also, thyroid is your baseline. The other key things are, again, the need for iodine, the enzymes that convert it, the role of thyroglobulin. So I ask you, what's the actual protein formed in a thyrocyte? It's not thyroid hormone, okay? What's coming off the DNA is actually thyroglobulin. And that's going to form that. And this is made from amino acids. So does it need a carrier protein?
No, it's not steroid.
No, it
But
shouldn't
it acts
ordinarily,
like a
except for the
steroid.
fact that...
But it acts like a steroid.
Huh?
Doesn't it act like a
You start where I can hear you and you fade off.
It acts like a steroid.
We're losing you.
I'm not confident in my answer.
That's okay. I will make you confident if you just give me a This is protein-based, but what does it act like? A
Steroid.
steroid, which is what is going to have thyroid binding globulin. It's going to be carried by a protein, very unique. Also, how long does it last? How long are its effects in the cell? Long lasting. All the features. Remember the first class where I go, why did we do this basic stuff? So you know it's acting like a steroid. Easy, people, easy. I can be here all night. I got no place to go. It's up to you. I don't know. So you gotta get hungry? Who wants to order pizza?
I know a lot of times, you know, they're put different time frames, so could you phrase two questions saying that, let's say that you have low T4, what is it versus what will it do, so that we know how you'll phrase both of those questions, because depending on, it will be one thing, and then you're gonna initiate a feedback loop.
Oh,
How
yeah.
would you differentiate those questions so that we kinda see an example?
I've done that on quizzes. I try to give you the setup. I know what you're asking for. I thought I did that. So we have a patient, either I give you symptoms and that sort of thing. Not sure what you're asking.
So, alright, so right now, if their T4 is low,
Yeah.
okay, you know that at this second, you have low TRH and TSH. However, it's going to initiate an increase in TRH, which is going to increase TSH, which is going to increase T4 and T3. So it's all of what time frame?
Wait, go back a bit.
We got hit heavy phys 1 on which one initiates first on the parasympathetic versus sympathetic
Oh,
cell and
okay,
blood pressures.
okay. All
Are you
right.
gonna hit us at the exact occurrence of one over the other?
So
Or
like,
the
the blood pressure
levels
doesn't
that are
raise
necessary?
instantly.
What I would do is, in my head, I would go like, oh, I want to give you a scenario. That's why I might make this a longer question.
Yeah.
So we have a symptomatic patient, we draw bloods, right? We can see the TSH level, so you can predict what it was. But you're right, if you just see a TSH level just sort of out there in space.
Yeah.
So I say somebody has an elevated TSH level. The best I could do with that is if someone had an elevated TSH level, would they be hyper or hypothyroid?
Hypo.
I don't know that you can differentiate.
TSH level. They have an elevated TSH, it's above normal. It's like shouting at the thyroid.
So that's low.
Then they'd be hypothyroid. You don't need a time sequence for that, you don't need anything, you need to stop and pause and say, why did I give the wrong answer? It's a different story. Anyway, that makes sense? We're still on thyroid. Hello, hands.
Can we go through like what you're doing on the board with different glands? Because I
Yes,
think this is
we
what
can.
people really need.
It's like the rat.
Let's do cortex.
Yeah, well, some of the rat, let me clarify something here. Does anyone have like a, some
No, but I see
erase a
something
board with,
curious.
what?
I can go grab a paper towel.
It would be nice.
Thank you, Corla.
All right, thank you.
Yes.
Oh, I'm standing.
It wasn't me.
I'm gonna need more. We have so much to learn. All right.
It's two-sided.
It is two-sided.
It's what?
The whiteboard's two-sided.
Yeah, but there's all this, this
Oh.
one stuff.
Just kidding.
Remember this?
No.
Nailed that. Who comes behind the blackboard? Anyway. Lawsuit. We gotta go talk to Dr. Morty.
Words, those fatty acids.
You struck a student with a whiteboard? Jesus, right? We should go on and try to do this with as many examples as possible. Agreed?
Yes.
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 But everyone seems comfortable with thyroid.
Yes.
Take a deep breath, work with it. Thyroid is the base, that's as easy as it gets. The thing that's similar to thyroid, just to put them on a par, is your adrenal gland. Sorry. Release hormone, ACTH. Okay? But what's unique about this is it's going to hit the cortex. What hormones are going to be released? Cortisol,
Aldosterone.
definitely. Aldosterone.
All androgen.
Throw a few androgens in there, we're done. Excellent, okay? So if I was gonna ask about effect, it could be one of the things, it could be about salt levels and blood blood pressure. So for example, if somebody has an increased level of ACTH, here's the other thing you're gonna know. Let me do the things you're most likely to see. When we did it in the lab, so you have something to fall back on, right, we primarily talked about cortisol. And we talked about Cushing's and that sort of thing. I wouldn't necessarily want to throw the stratification, I want to save that for the practical, teasing out the disease, but you should know the effect of cortisol, elevated cortisol. What effect would that have on the body? I might give you the patient to come in as an example. I'm saying this right. I'm going to have like very simple questions, but then I'm going to give you a story. And the story is supposed to guide you. You have clues. So if I think it's really complicated, well, then you would go like you're thinking of like, well, what does the patient look like? What do we have for symptoms? What do we have for that? Yeah, that's a level 3 question. So you're not just guessing. This is just this. Here's a level 1. If this is increased, what happens to this? That would increase. That's too easy. But again, I got to sit down and think about this. Oh, bummer.
Cortisol size.
Ah, we'll borrow the lab. Okay. Somebody has symptoms of that's the same question though. Somebody has symptoms of hypocortisolism. I want to get a lab, right? Which, and you want to save money for this poor individual, they don't have to spend a whole lot. And I want to know, is the problem here, here, or here? What lab would I get?
ACTH.
Hmm?
You could check it with ACTH.
Check it with ACTH, the same way we did with thyroid.
So we have.
Did folks get a hint of that?
Yes.
Because it's the same way, because it's like, well, I don't want to spend a lot of money, so let me get this, let me get some ACTH. They've already got the symptoms that tell me it looks very Cushing. I'd probably get a panel in real life, but we're just making a question for the exam, okay? So if this was low, okay, wait a minute, are they hypothyroid?
You said hypo. I don't
Hypo?
know.
Do that.
Oh, thank God. Okay. I'm so confused.
They're hypothyroid. Okay. So if we see this, hang on, where's the problem? They have a tumor in the pituitary, or there's something wrong with the adrenal gland? They're hypo,
You saw high ACTH.
they're low on cortisol. I forgot what we
It
just
would
said.
be the cortex
Low on cortisol, right?
problem, right?
I gotta remember to write stuff down.
So
So here's our patient. I won't give you the symptoms, but I'm